So this is a spreadsheet with sample data for the assignment. I removed, I used the first 120 rows in this. So you would see somewhat less data than what you are expected to do in your assignment. So some of the quick things that I have done here is computing the cost, and the cost formula is based on F2 times 0.5 plus G2 times 0.3. And the profit formula, E2 minus M2 in this case. E2 is AMT reimbursed and M2 is the cost. So these are the ones that we got here. And in terms of A2, it's simply running a pivot table based on all the data in A1. So that you should be able to do quite quickly. A3 and A4 is where I got the LOS and profit onto a separate sheet. So I simply copied the LOS and then I also copied the profit from this sheet and then pasted them into this A3 and A4 spreadsheet. Once I have that, I should be able to draw a graph, and that I can go by going to insert and recommended charts, and then profit, and that should give us this type of a graph. And inside this, I could add a trend line, and adding that trend line, I could choose linear. In these display equation, display R square. So if I do that, then I should be able to see the equation and the R square value. Once again, this equation would be different when you complete the homework, because I'm not using the complete set of data. I'm only using sample set of data. For LOS, what we could do is the simplest that you could do is just copy these, right? So these two columns you can copy, and in B2 you can insert these copied cells, and now I'm going to delete these two things. So I have the LOS in one column and profit in another column. And I have the first 120 rows like I mentioned before. Now I take this data and I can sort this based on LOS and smallest to largest by going to data sort. If I do sort by LOS, I get this and I click OK. So I don't have a high-tech way of doing this. I'm not trying to do it the high-tech way. So using complicated formula and things like that. In this case, I can just get once I sort this data, 1 through 4, I get this data, and then I copy these cells, and I paste these cells here, and then 5 through however long it is, the length of stay, I think I do find 47. So I go until that point and I get all those. So I place those here. And now it's a matter of running ANOVA or t-test. I think one thing that I noticed, and some of you asked questions, and rightly so, by email, is that why do we need to run ANOVA? Why can't I run a t-test? So you are perfectly fine running a t-test because we have only two groups, length of stay less than or equal to 4, length of stay greater than 4. So if you want to use just a t-test, that is fine by me. So let's go through a t-test with perhaps unequal variances. I'm not sure how the variances of this data, whether they compare relatively close to each other or not. So I'm going to run this unequal variances. And if you run that, the first variable is this, and sorry, I think, and then the second variable 2, would be this, and labels are in this, and the output range would be in perhaps G1, and click OK. You should see the t-test difference. Then the variances are about 13 times or 13.5 times that of length of stay greater than 4. So, sorry, 1.3 times or something like that, not 13 times. 13 times would be too much. So 1.3 times. So you could use equal variances and see how it is. But with a p-value this significantly low, whichever test you run, it's not going to change the interpretation for you. I would suspect that it's almost likely that with equal variances also you'll get a significantly low p-value. So there are significant differences between these two. So that's one way to do the length of stay less than or equal to 4 versus length of stay greater than 4 versus profits. And you can run ANOVA as well, and ANOVA would give very similar results in this case. To figure out which length of stays gives us profitability versus which length above which or below which we are no longer profitable, we want to be able to do we want to focus on this equation, right? So this trend line equation, that's why this trend line is the most crucial, right? So this is a algebraic equation. It gives us the best fit kind of thing. And so we take this and then we solve this equation. So y is the profit here, and 15 minus 15.23 times 0.8 times length of stay is x, right? Plus 4653.1 is the profit that's computed using length of stay as a parameter. So if I write this equation, I get this type of equation. And so I equate this to 0, right? So if this is 0, then that means that I have minus 1523.8x equals minus 4653.1, right? So if I take that and then flip them around, so if it's 1523.8 times x is equal to 4653.1, right? So which length of stay makes it profitable? So which is makes it 0? That's what we are trying to find. So x equals this divided by 1523.8. So in my case, with this limited set of data, I'm finding that when the length of stay is equal to 3.05, approximately 3 days, that's when I break even, right? So my profit is 0. If the length of stay increases above this 3, then I can clearly see in this equation, if it is, let's say I plug in length of stay of 4 times 15 minus 15, 24 would be about 6,096, right? So then I'm losing money. If my length of stay is 4, I'll have minus 6,096 plus 4653, then the profit is a negative number. If the length of stay is below 3, for example, if I have 2 days of length of stay, then I have minus 3,046. 2 times 1523.8 would be minus 2,046. And so I'm making money. So below, so what this is, using this, what I'm concluding is that length of stay, so length of stay, which is X less than or equal to 3 is profitable, right? And above 3.5, I'm definitely not profitable. So I want you to use this regression equation, and that's where that regression analysis that you have been doing for at least for a couple of these assignments is very, very helpful for you for forecasting or predicting and things like that in your role.